Did the ammeter's resistance confuse you? Not sure how it affects the reading? You're not alone. This exact point challenged many students in JEE Mains 2025. But here's the good news. In the next 3 minutes, you'll understand this concept clearly and never make this mistake again. Welcome to the 7th video in our current electricity series. Let's get started. Let's start by breaking the ammeter into 2 parts. First, an ideal ammeter. This has 0 resistance and simply measures current. Second, the internal resistance of the ammeter. In this case, it is 240 ohms. So effectively, we replace the ammeter with an ideal ammeter in series with a 240 ohm resistor. Now, look at the circuit again. This leaves us with 2 resistors, 240 ohms and 10 ohms, connected in parallel. Let's solve this parallel combination. Using the standard formula for parallel resistance, we get an equivalent resistance of 9.6 ohms. Now, we simplify the circuit. After a slight rearrangement, we can see that this 9.6 ohm resistance is in series with the 150.4 ohm resistor. So the total resistance becomes 150.4 plus 9.6, which is 160 ohms. Now, the circuit is much simpler. We have a 160 ohm resistor, an ideal ammeter, and a 20-volt battery. Now, we apply Ohm's law to this simplified circuit. The total resistance is 160 ohms, and the battery voltage is 20 volts. So, the current is voltage divided by resistance. That gives us 20 divided by 160. On solving, we get 0.125 amperes. That is equal to 125 milliampere. This is the total current supplied by the battery. Now, return to the original circuit. The total current of 125 milliampere flows through the 150.4 ohm resistor and reaches the junction. At the junction, the current splits into 2 branches. One branch has the ammeter with 240 ohm resistance. The other has the 10 ohm resistor. Let the current through the ammeter branch be I1. In parallel, current divides inversely with resistance. So, the branch with higher resistance carries lower current. To find I1, we use current division. Multiply the total current by the resistance of the other branch and divide by the sum of the resistances. So, I1 equals 125 milliampere into 10 divided by 240 plus 10. That is 125 into 10 divided by 250. This gives 5 milliampere. Hence, the ammeter reads 5 milliampere. That concludes this solution. Thanks for watching. If you found this helpful, share it with your classmates and subscribe for more clear, animated solutions. Comment if you would like me to solve any particular problem. In the next video, we will solve the question shown on the screen. See you in the next video.